Hey everybody, this is Larry. This is me going Q3 of the weekly contest 374. Count complete substrings. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, it took me a while. It took me half an hour and more with three wrong answers. So definitely a difficult problem. So the core part about, so I kind of tried different things. I thought that I could do it with dynamic programming and stuff like this, but I just couldn't get it to work. And one of the cases that I failed on with dynamic programming is I thought that I could think about it as connecting adjacent. I did a dynamic programming approach. I also thought like you only have to do like look back approach for like a certain amount. But the case that I fail about is something like this because now AA is a word. It's a complete substring and BAAB is also a complete substring and they overlap each other completely. Even though I thought that initially I thought that it could not happen. So that was one of the cases that I failed on. What I end up on, and to be honest, I don't know the best way about this is because on Python this is very slow, and I think to be honest, also I think Leetcode is just kind of messed up on this one and Q4, which we'll talk about in that video with respect to timing, because I think this my solution ends up taking 26. Oh, sorry, spoiler alert, but it ended up taking 9 seconds. It probably shouldn't. I don't think my constants are that high, but in any case, but the idea here is that it's just sliding windows, which is easy to say, but okay. So the reason why sliding windows works is that there can only be at most 26, which is the size of the alphabet, number of uh, distinct characters, right? And or distinct unique characters or whatever, right? So that means that you can test it for one one character, which is length k, or two characters, which is length 2 times k, three characters, dot dot dot. I mean, you're smart. You figure this out, right? And this works because then now it becomes a sliding window. What are we sliding on, right? Sliding window on basically, let's just say length L for some L now, right? Then it's just a regular sliding window where we have each character appearing k times, and we have I don't know, yeah, L dotted by k characters, right? Something like this. I mean, I think I wrote this in a weird way, but you get the idea. And because of that, you just keep on going, and it's a very standard sliding window if you think about it. Or that's a prerequisite. So if you don't are not strong with sliding windows, I do recommend you go back and do other sliding windows first, and then we'll talk about and then you understand this one much easier. And then the second part is that the difference between two adjacent characters are most two, right? And because of that, what I did is just that I restart the sliding window. So basically, my sliding window is left and right, and the idea behind sliding windows in general is that you move to the right and you also move to the left to catch up. In this particular one of your constraint is the length, so you're just doing one by one. But in this case, if you have a thing that is disconnects the thing, then there's no need to slide any, or like this you can think about it as the sliding window starting all the way to the next part, right? You're starting a new window because it doesn't connect in any way between the two things, and there's no possible answer behind it. Maybe the cleaner way to think about it is that you keep on sliding until that's the case. So then now you have a window of 0 or 1, depending on how you want to say it. And that's basically the idea. And this goes up to alpha characters, where alpha is the size of the character, the size of the alphabet, and you have the length alpha times k, right? So what's the complexity here, right? It's going to be alpha times n, because for each sliding window, it's going to be O of n. Yeah, roughly speaking. Maybe I think I've written it in an awkward way. Hmm. But in any case, you could probably have, yeah, I'll talk about some optimization that you can do, but you could do it all of time and all of alpha times n space. No, is that true? All of alpha space. Oops, sorry. But yeah, and this is basically what I said. Basically here we go length. L is the number of times each character appears, and then basically I do an early termination, and then I just do a bunch of stuff. Yeah, this is regular sliding window. Like I said, if adjacent characters are too far apart, then I just restart the count and I restart the left, so that I move the window all the way to the left or to the right and restart one. And then after that, we increment the current character, regular sliding window stuff. Here, if the window is too big, we just keep sliding to the left until it's good enough. And then here is the count, and this is basically saying, okay, if the current count is equal to k, and the length of count is equal to L, meaning that there are L distinct characters. Oh wait, I think I messed this up. It's the number of distinct characters. Whoops, sorry friends, I messed it up. Characters, and k is the number of times each appear. Yeah, so then if the number of distinct characters is equal to L, and if the size is correct, like the window is big of the right size, then we do this check. You can actually do this in all of one time if you do like a sliding thing. So maybe that speeds things up as well. But yeah, I guess that does speed it up by a little bit, because I think the way that I do this, technically this is O of alpha or something, O of L, and it becomes O of alpha squared times n, which is a little bit sloppy. But yeah, I guess another way, I guess let's try this optimization then. Live. Let's do it live. Live. Good. Is equal to 0, right? And then now we add if count of C is equal to k. Good. Increment by 1. And then also if count of C is equal to k. Good, we subtract 1, because that means that we're adding 1, so then this is going to be bad, right? And then we do the same here, right? So if count of word of left is equal to k after subtracting 1, then we want good to increment. If this is all right, yeah, you go to k, then good, we subtract 1, same idea. And then now we could just skip to and good is equal to L. And there you go. Maybe wrong though, but we could actually skip a bunch of the other stuff. Good, L was actually probably good enough. Well, it's good enough if we are correct. What line are we looking at? 60? Oh, whoops. Alright, let's give it a submit, see what that fixes good. Or maybe it still times out, who knows? Oh, Oh, I don't reset this on here. Good is equal to 0. Oops. I forgot to reset that. Yeah. But this should be faster. So apparently it's still not that fast. Okay, well, the optimization actually slowed it down somehow. That's actually surprising. I guess all these. Oh, because I do this. Okay. Well, still, it's actually kind of, I don't know. I think Leetcode is just really bad on this problem for Python. I don't know how many people did it with Python or whatever, but it seems like my constants are not that high. Like maybe they're not super fast, but they're not super slow that it should cause this much of an issue. Yeah, I don't know. That's kind of weird. Because we don't do anything that intense other than maybe this. But, I mean, if I just wrote, is that better? I don't know. Let's try it, I guess. I don't know. This is really annoying, to be honest. My battery stuff. Oh, whoops. What again? I have to do it here. But yeah, I don't know. Well, in any case, you can go back to my previous code to see the one that actually submitted. I don't know why this is like. I don't know why Leetcode is so stingy on. This is just wrong now. Do I have some typo maybe? Yeah, sorry friends, I messed up. Let me pull it back in. I don't know, friends. I think like I said, I think Leetcode is just overly stingy. This is over like 26 times n is not should not time out. Right? Like that's 2.6 things. I don't know. I don't know what to tell you. Leetcode is because I feel like in other languages it's not even close. But yeah. What's my submission? They don't let me copy my submission. Okay. Let me see if my submission would still be good. But that'd be funny if it times out now and I'm just like, yep, I lied to y'all. Okay, I don't know why. Like, but yeah. But anyway, that is the idea behind this farm. So yeah, let me show you the top. I guess this is actually the entire code. So yeah, let me know what you think. Let me know how. I mean, the idea I think once you get to it, it's not that bad. It's a tricky idea. It's still and it requires thinking on it from another dimension and stuff. So it could definitely be tricky. But yeah, I gotta charge my batteries literally. So I'll see y'all later. You can watch me solve it live during the contest now. I think the tricky part is because I really thought that I had sorted it. So once you kind of had that idea, you just don't. I don't know. Today it's just the algo is okay, but the brain is not functioning on implementations. All right, let's go. Let's finish on Q2 even. All right, tilted. Don't get tilted. Focus. String S of word is complete if S occurs exactly k times. The difference between two adjacent characters is at most 2. What does that mean? Two adjacent characters in S. What is S? Okay, so Each character in S, okay. 2 adjacent characters, okay. Complete substrings, okay, so let's see. Okay, so then is it K is 2. Then you come. So the answer always just combines. Is that true? So sliding window for the minimal. And then just like count kind of thing. Okay, yeah, fine. I don't know if it's TP, I'm too lazy to name things. K times. Okay. C dp count C increment by 1, right? And then wow is greater than K. And now we have to see if everything left in, I guess that's only O of 26, right? Is that too slow? Otherwise, how do we do it? If count of C is equal to K, then okay, fine. This is a prerequisite anyway, I guess. Then okay, then I guess we can, that makes it okay, maybe. I don't know, if it times out then I blame it on Python. Actually, I don't think I could do that. I think it actually gives me a violation. Maybe off by 1. I don't know. Well, that's not quite right, but yeah, worth a try. Let's see. This is 1. This is, oh, it's 1. What is this left? Is it left -1? Because it's the one outside the bounds. Oh, and where did I'm not checking the not checking the JSON characters, but I'll fix that after I fix this. Why is this wrong for that? So 1, 1, and then okay. So I see, because this is now doing this, because now it's BBBCCC. How do I remove as much as we can? Man, my brain is not working today. I forgot the consecutive thing. Okay, so as soon as it matches, then we can take it out, right? How do we take it out? And also, this is not quite right either, because I do something like a. Am I doing it a stupid way? Maybe. I have too many A's. For each one, do 26. Twenty-six, 10 to the 5th. No, that's too much. Because the problem is that now, I mean, I think I could fix whatever, but it's not quite right. This part's fine, because if this is good, then we can just say We could just reset, right? But that's not even good enough. I mean, this fixes it, but now we have an issue with. Now this would give me 6 instead of 1 or 3 because now it has too many, right? So now we have to figure out how to combine them in a way that is and the worst case is A, B, C, D, E, F, G, or A to Z, and then 1, and then 26 times. Can I do it in a smaller way? Without. I guess with bit masks. With mask and binary search, that's way too complex, isn't it? Oh, and I still haven't done the adjacent thing yet, have I? Huh. Well, I have to do this in a better way, don't I? This is not good for my going to bed early plans. I mean, this part we can change it, but it's not even really a stack. I just used the last items. I don't know. We'll see if this is good. I forget what's the opposite of char. I'm blanking out. Is it char? Oh no, ordinate. Okay, yeah, that's right. What am I doing? Why am I doing this way? All right. The last character of it. Yep, okay, fine. Actually, we want a Q. Yeah. And now everything from QI and forward is no good. Otherwise, add one. Here we want or something like that. I'm not even on Q4 yet. Should be 6 if correct. I still missing a step. Okay, no, but I mean this is true, but I'm still missing a step, which is the inter thing. Yep. Wait, what? Oh no, this is 1, but this should be 0, right? So something like, okay. This is so easy to build. That's not true, but still not confident about it, but let's YOLO. I'm tired. Please. No. Oh, okay. Easy answer to fix, maybe. Expected 1. Okay. That is actually, I don't know why that is, but easy to debug, not fix. We'll see if it's easy to fix. Not this part. Okay, so it's equal to k, but it's not. So this part is returning false. How do I know that there's a small case and we don't need it in the future? Wow, this is a hard one. Jeez. I thought I had it, to be honest, but it's minimal, whatever it is, but then how do we know that AA can be good? And also B, if this is 2, BAA B is good too, right? So if I have something like this is probably wrong, because it's returning 1, but this should be 2. 1, 2. So my idea is wrong altogether. I thought I could build it up from components. And I guess my other direction was probably the way to do it, but it feels so slow. 10 to the 5th. How are people doing anyway? Well, people have finished. People finished Q4 first, so maybe I am making the mistake of getting stuck on this one. I thought it was easier though, to be honest. Well, I didn't think it was that hard, but clearly I'm wrong. can I change my answer to this to fix this? I don't think so. I think the way that I wrote it, I assume that this is not a case, but I just never thought about it. Even like ABAB. No, ABAB should only have one actually. That's fine. Did I do 26 sliding windows? I guess I could do 26 sliding windows, right? Okay, yeah, I guess that could work. Is that true? Yes, okay, yeah, you're right. What am I doing? Larry, Larry, what are you doing? My naming is terrible. Length of No, I got rid of my cases by accident. Yeah, I mean, maybe these are all I need. Left. Oh, whoops. Okay. I'm only having two. And I made a mistake, but okay. Only length once. Length 2 is no. Why is length 2 no good? Also, this is terrible. This is I meant to do this when I was writing it, but then I think I just got distracted. Okay, I mean, this should be strictly better of it. Okay, but now I don't know if this is fast enough. I guess I could have eliminated some loops, but if this is too slow, then it's still going to be a little bit awkward. Oh, well, wrong answer after all this time. That is actually weird. Why am I returning 6? Technically, I don't need this. This is only making it confusing. But still, J and Q. Why? Well, is equal to 2? Oh. But how? Doesn't this fix it? Well, I'm included, but oh, really silly with the silly mistakes today. Like I did it in the other place, but then I just kind of got lost and forgot. Please don't time out. I want to sleep. I mean, this is not super slow, but I need to be a little bit better about it. Let's see, right? If L times K is greater than we may still time out, but at least it should be much faster. Thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, the explanation, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.